great to be here at Automobility. I'd like to have my panelists coming up and join me. I'm at Nvidia. We are the AI computing company, and we're really excited to be here, be a big part of the automotive industry. But as Brian was saying, it's all about how we're using data, how we're using information, and what insights can we get from that. So what I'm going to do is we're going to all sit down, okay. I think, and you know, what we see is a sort of a trend now of data being used to write software, essentially. And this is impacting the transportation industry, but it's healthcare, it's finance, it's energy. Virtually every industry is being transformed by AI. So we actually are using AI to anticipate what all your questions are, and so we're going to be able to answer all those questions because we know what you guys are thinking. But what I want to do is have each of the panelists really quickly tell you what they're up to, where they're from, and we have a really cool set of startups being represented here. Some of them are actually in stealth mode, so they're maybe going to tell you something you didn't know, I hope. Yeah. So Sterling, go ahead.
Sure, yeah. Sterling Anderson, I'm a co-founder of Aurora Innovation. It's a self-driving technology company I co-founded with Chris Urmson and Drew Bagnell several months ago, or earlier this year. We're based in the Bay Area, California, and Pittsburgh, Pennsylvania. We are focused on partnering with the automotive world, specifically automakers and others involved in those orbits, to catalyze or accelerate the broad, safe adoption of self-driving and its attendant sort of social benefits.
Great. Sertac.
Hi, everyone. Sertac Karaman. I'm co-founder, president, and chief scientist at Optimus Ride, which is a venture-backed MIT spin-off based in Boston. In one sentence, we're working on providing electric, shared, and autonomous mobility solutions for smart and connected cities and communities. And our main focus is the autonomy software that makes this happen, and needless to say, AI is at the center of our approach. In addition to my role at Optimus Ride, I'm also an associate professor at MIT, leading a research group of 20, 30 people working on robotics and AI.
Xiaodi.
Hello, my name is Xiaodi Hou. I'm the CTO and co-founder of TuSimple. We are a autonomous truck company. We build autonomous truck solutions for highway, middle mile autonomous driving for freight transportation. And our company is based both in China and in the US.
So we have a number of different companies. There's hundreds and hundreds of startups now in the autonomous vehicle space that are using AI. Now there's a fundamental technology that can be applied in so many different ways. And I think what we want to do is really try to understand a little bit more about how are you using AI, and what ways is it able to achieve things that you couldn't do in another way? So Sterling, I'll maybe start with you, and maybe you can tell us a little bit about how your engineering team is really trying to solve some of these challenging problems.
Sure, yeah. So the engineering team at Aurora has come from a myriad of backgrounds that have been working on this problem, many of them for up to 2 decades, and have gone through several evolutions of various approaches, from very manual, sort of deterministic algorithmic approaches, now to more and more implementation of AI, or more specifically, applied machine learning techniques, whether that's reinforcement learning, whether that's imitation learning, or other techniques. We have used those in greater and greater measure. So at Aurora specifically, we started with a bit of a clean slate approach. AI or machine learning allow us to, if I were to categorize sort of the benefits of it to us in our system, I would call those probably threefold, right? The first is machine learned approaches allow us to more quickly and efficiently develop some elements of the system that designing the deterministic set of more manual models and algorithms would require a much more laborious and long-term effort to do. So it allows us to shortcut some of that. The second is machine-learned approaches allow us to leverage learning in particular for forecasting and for some of our planning techniques from what the human has done. So it allows us to really use or leverage to greater effect the data we're gathering from some of the test vehicles and simulations that we're running. And then the third use of artificial intelligence or machine learning that's really come to the fore in the last couple of years is its use in certain aspects of the problem that we really don't have a better solution for, right? I would classify perception in that bucket. I would put forecasting or the prediction of how other actors in a scene react to the movements of an ego vehicle or the actions of other actors. So those are kind of the three areas that I would say machine learning has really influenced the approach that we've taken at Aurora to the sort of what an advanced self-driving system would look like if designed from a clean slate in 2017.
So Sertac, you guys are developing shuttles, essentially, to drive around certain communities. What kind of results are you seeing by applying AI? And maybe talk a little bit about the timeline that you guys are on.
Yeah, so yeah, you're right. So we're kind of developing these types of transportation systems essentially for, like I said earlier, smart and connected cities and communities. And AI is at the core of our approach. So today, we call this approach AI, where we develop these kind of systems by using, for example, data that could be labeled, or by using, for example, simulations or experiments and so on. And it's a departure from like traditional way of programming systems, where you sit down and write a large fraction of code. So that traditional approach, sometimes we tend to call it like model-based approaches. So when you go out, you're writing some form of code. You say, okay, if this happens, then do that. If that happens, then do this. Essentially, what you're doing is that you're writing down a massive and complicated model into that system, for that system to execute essentially that model of the world. And what we've seen in the past few years, maybe going back 10 years, is that there's this new way of programming, where you can use labeled data and so on, that actually far outperform what you can do with models. And maybe beyond that, not just far outperform, but we can do things that we couldn't do with models. Like specific things are, for example, detecting humans or detecting cars, but sort of going forward, we're, for example, working on detecting behavior. So we're in environments where there's a lot of people walking around, and we'd like to be able to blend into that environment. We'd like to be able to not take over the streets, but be able to share that, for example, with participants of that community. So to be able to do that, we use, for example, AI to understand what people are about to do just by looking at how they walk, for example. And those are kinds of things that I don't think we will be able to write down a model of how that would execute.
Now, Xiaodi, I think you wanted to add something there?
Oh, yeah, sure. I think the key to make AI for autonomous driving really a product is to make the machine learning transformation from a workshop style to a factory style. I think this is really what we are striving very hard to do. I think this is also maybe Aurora and Optimus, right, is also doing this. First of all, we have deep learning. And once we have deep learning, we can dissociate the human brain into the development of the model itself. We just put the data into it, and the model learns by itself. And by doing that, we're actually streamlining the entire process from data to the learning system to the inference model. And that is how we can build a real product out of the AI, instead of building some laboratory thing where we have 3 PhDs working together on a very handcrafted model, and that thing never worked in the real world.
Right, great. So I think we're going to do a real quick polling question. You guys know what you're supposed to do. Let's see, the question should be popping up on the screen.
While you're waiting for that, just one thing to add on that last point. I think it's critically important that we understand that AI, deep learning, other manifestations of modern machine learning are not hammers to be taken to every nail in the self-driving problem. I mean, they certainly can be, but I think I would characterize the greater usage of of modern machine learning techniques rather than some of the classical approaches as one that has to be precision targeted, and it sort of shifts the onus from what was previously, 10 years ago, I remember having a book this thick on my desk that simply described tire interaction mechanics with the road, right? And I incorporated that into all of my models of how things worked. I no longer do that, but in the new world of applying machine learning, the problem has simply shifted to one of, what is the right machine learned approach to use? where are you going to, what's the data that's required to train that appropriately, and how are you going to acquire and use that data? And we've seen and we've heard from other speakers today references to things like greater uses of simulation and other amplifiers that allow us to generate more data with less. And I think it's important that we realize that machine learning is not just a sort of brute force tactic. It has to be precision targeted if you're to develop a system that you can appropriately validate with a sufficiently small sample size.
Right, and that's what we see as, again, there's obviously safety is at the forefront of everything we're trying to do. And what that means is the need for redundant systems, diverse systems. So there's going to be many different algorithms running simultaneously in the car. To your point, I agree that you have this fundamental new computing model, essentially, but you still have to refine it for those specific uses. And there's going to be a variety of both AI and other types of computing and other types of algorithms all working together, no doubt about it. So I would have thought that this savvy crowd would have been more involved in AI than it is. And to me, that says we have a lot of people in D that are going to be left behind if you guys don't get on the ball and start learning about how AI is going to transform your business. Oh, okay. But let's get back to some of the questions on transportation specifically. Like you said, AI is not going to solve everything. But I'd like to understand, what do you still see, and we'll start with you, Xiaodi, some of the problems you're still trying to solve as you have these massive trucks that are going to be driving down the highways. What are still the challenges that you're facing?
Okay, so I would say one specific challenge that is for trucks. I will leave the sedan challenges to Sterling and Sertac. So for trucks, the observation distance has to be very long. Otherwise, because the braking distance for a truck is about 75 meters. So we have to see further than 75 meters, maybe even 200 meters, in order to oversee the obstacle, the situations on the road, so that we can do the maneuver in a more smooth way, rather than just having a hard brake all the time. That's not possibly a product. So that's the biggest challenge that we're facing in terms of trucks. And that is in order to solve that problem, we have to do a lot of work, including the hardware of how to build a camera that could see further, and how to build the rack that could house the camera so that it doesn't vibrate like crazy, and how to deal with the control and motion planning thing, and taking the synergy of the two components in order to make sure that the braking or swerving is kind of like a smooth process. So that's a very individual challenge that we're facing for driving.
So I see simulation clearly being a big part of what you're doing to create those data sets to be able to train a system before you even deploy it in the car, to be able to simulate all those different crazy scenarios, all the dynamics of the vehicle. Sertac, how about you? Other challenges that you're facing?
Yeah, I think that I would sort of go back to, while I agree everything here, I would go back to something that Sterling said earlier, is this kind of really finding the right approach of AI, because there's a lot of different approaches now, and they all work. They all work for certain domains and so on. And really finding the one, targeting to the one that really works the best for the kind of application that you have, and that requires a lot of expertise. Not just that, but we realize kind of taking that AI and putting that together with model-based approaches as well, particularly for the things that you said, for example, safety. Sometimes safety is there with AI, but guaranteeing safety is another thing that you can have. And sometimes, you can have with models, you can guarantee safety at certain places, at certain applications, but you can take AI and amplify that. So that's one of the things that we're doing and that we find challenging, really, on the science domain.
Mm-hmm. So a lot of you are in either Silicon Valley, you're in Boston, you're in China, and there's these hubs of AI development going on all over the world. But there's a lack of talent, right? This is a whole new field. There aren't enough people who understand it. Kind of two-part question. I'd like you guys to kind of ponder this and share your thoughts, though. But how do you compete as a startup? How do you compete for AI talent? We have Google's rumored to be putting out multi-million-dollar packages to attract talent that specifically are deep learning PhDs. But so how do you go about attracting this talent? And then also, what advice do you have for people looking for jobs? So,
Sure, yeah. It's a great question. We've been fortunate in the talent department, I think. I think at the latest count, we're pushing 300 collective years of self-driving development experience in the team that we've built.
Wow.
It was important to us that we start with the kernel of those who really understand fundamentally the many problems and facets of this space. I think about it in my mind's eye as sort of a three-dimensional surface with this sort of pockmarked all over with local optima. And without a sufficiently comprehensive view of that space, it's very easy for one to drop in on that surface and sort of steepest descent, find their way to a local optima as opposed to bounding the global. And so we've tried to be very careful about bounding the global, but from there, to your question about talent, once you've got that core of those who really fundamentally understand the problem, some of the advanced machine learning scientists who really understand how to apply it here, from there it becomes more about talented hands, right? And so I would characterize the data need for Aurora at this point as one of both AI experience but also engineering excellence. We're looking for those, if you're tremendous at what you do, in particular if you're a software developer that is just very, very good, we can amplify your abilities, putting you alongside an expert who really understands self-driving. And so that's kind of how we see, the right team evolving, and that's kind of how we've built Aurora to date.
Right.
Yeah.
So Tash, how big is Optimus Ride right now?
Optimus Ride is now almost getting close to 50 people. We're quite large now. Given how much we've been along and how much we've been on the scene. But I think that in terms of kind of attracting talent and looking at what we have, and sort of challenges are similar. We're also fortunate that we're based in Boston, neighbors to MIT. We were just coming to this panel, and we were just talking about how the panel turned out to be like an MIT Caltech type of a distribution. So I was saying that MIT is, of course, is the best, but we'll give my colleague that Caltech is also very good. So we've been very fortunate to be, for people who may not know, Sterling has spent quite a bit of time at MIT as well. We've been really fortunate to be neighbors to MIT and really recruit from MIT quite a bit. We have a lot of people who come from MIT. In addition to that, just like Sterling said, we're also we're building production level software. And that's also important. Not just you have to have the science, but you have to have the engineering as well. And so we have a group of people who can do that best also. We talked about Google, but like we hire from Google, for example, quite a bit. And that's a place where people really learn how to build that kind of software. In terms of attracting the good talent, I think the biggest thing is to really have the challenging problems. I think that the most talented people out there are looking for problems. And you can have $1 million packages to attract them, but the thing is that the truth is, we as startup companies here, we're also creating similar value. And maybe you and your companies, you can also afford to do that and create similar value. I think people get attracted to that. But the point that I was going to make is that people are really out there looking for challenging problems. And I'm a roboticist by training. I've done a lot of work in AI, and I think that this autonomous driving is the most challenging and the most rewarding problem out there, rewarding economically as well. Like, there's a huge market of that happening. You could think that flying, for example, for AI will be harder, but no, the harder one is actually going on the road and interacting with all that complexity at that high speed to be able to do that. So people get attracted to that is what I find.
So what about in China? How does that differ, would you say, maybe from Silicon Valley or other markets here in the States?
Oh, actually, we have two offices, one in China and one in San Diego. And in San Diego, we're hiring like crazy from the talents from the US. So I think your question is great. Yeah, we do have a lot of challenges when we're like acquiring people who are also got offers from those big names. But on the first hand, I believe more in potential rather than in existing achievement, because like very, very little portion of people today has a degree in autonomous driving, because this is the new stuff, right? And we need some new talents who have the capability of solving this new problem, irrespective of the exact problem they have tried to solve before. As long as they have the right tool, they have the right mastery of the machine learning, statistical learning background, they will be really good in picking up this new challenge. That's the first thing. And the second thing is that we believe that as a startup, we are having a very thin barrier between different groups, so that this is another advantage. We can tell people, OK, so once you're in TuSimple, you will be rotating in different groups, and we are like project-based, and every single project may last a very short period of time, so that you have the chance to get to know the entire horizon of autonomous driving instead of focusing on your own silo for like 3 years. So I think that's a very, very attractive point for when we like pitch to people to convince them to join.
That's great. So we're basically out of time. I have one final kind of lightning round question. Sertac, we'll start with you because you were in the middle and you didn't get to start it. But suppose we're AutoMobility 2018, a year out, and we're looking back. Tell me, what's the one thing you feel you're going to be most proud about that you would have accomplished? What's your goal?
Optimus, right. So we just made an announcement today. We're kind of started announcing some of our clients. We're now kind of providing autonomous mobility shuttles, as you call it, transportation systems, we would like to call it, in certain communities. And I hope that we come back here and we'll have quite a few. And I hope that some of you have actually taken a ride in our shuttles, where you've called them and they came in, no driver, you jumped in and it took you somewhere. That would have been great.
All right, Sterling, I know you're still in stealth mode, but is there anything at a high level that you really want to try to be able to, to unveil in the next year? Maybe come out of stealth mode, but...
Yeah. So a year from now, you'll know much more about Aurora. You'll know about the scale of our partnerships, which we've been very pleased by the reception for our technology and our team. You'll know more about the team. I'm extraordinarily proud of the people that have come to Aurora, and so I hope I look forward to sharing that with you all in the coming months.
Sounds great.
OK, so yeah, my ambition is we wanted to be the first commercial-ready truck fleet in the world, period.
Sounds great. Well, thank you all very much. Really appreciate it, and I hope that answered all your questions.
Thank you.
Thank you.